Hey everyone, this is GeoWill from Left Man Productions Squared, and we're back today to do a little more work on the developer's vlog for 10 for Space Crusade. What I'm doing right now is, and for the rest of the week, is I'm working on the code for what all ever features are left on the leftover from 0.5 build 4 that I had not gotten to yet. And so that's what we're working on now. It's just essentially going through and doing the casino stuff for the moment. Currently, I am working on the blackjack code still. I've made some really just major changes in the way that this is going to work. Originally, I started out, as you may recall, having the hands be a vector of vector strings. That's part of game. I've done away with that idea, and I've created a new struct called hand. You can see the header over here. It's just essentially has a vector of strings and a string called state. And what happens is that the CAI class now has a vector of hand objects, and so does game for the player. So what happens is that we essentially just create a new hand object in the vector, and then load in the card objects into that for the hands for the AI dealer and the player. And the good thing about this is that it can accommodate any one of the card games: blackjack, poker, Texas Hold'em, and Omaha Hold'em. Those are going to be the three poker games we'll have, as well as blackjack. So it just allows us to have, a little more versatility than having to go through and say, okay, we go to this vector, we go inside of that vector, and all that other crazy crap, and have the bracket iterators for the vectors, and trying to track all that. Instead, we just go very simply from a vector to the class to the vector in that class, and then access what we need to. Now, I did add some extra not really needed complexity in how we deal with the aces. So here you can see what I'm talking about. What's going to happen with aces is that the AI, which is automatically, and for the player gets to choose is what the value you want A to be, the ace to be worth, and that's indicated with an A1 or an A2. A1 means that the ace is going to be worth 1 point, and A2 means it's going to be worth 11. And then that's what these will track, is essentially, okay, so if the substring comes up with an A1, then that ace is equal to 1, and so it processes the value as a 1. A2 means 11, same thing as with the A1, processes the value as an 11, so 11 gets added to the int card values vector, which is then iterated through. We get the total card values, or total value of all the cards, and then we use that to determine what happens down here. So this is essentially the what happens after your turn ends. So if you haven't stood, in other words, if you're taking the hits and you're not standing busted or anything else, and we go through here and we say, okay, so we want to take all the actually it starts up here. We want to go through the current hand, because the player and the AI can have one or two hands. So it iterates through each hand if there is more than one. Well, it just iterates through whatever number of hands there are, and then for each hand it goes through and checks to see what happens. So first we have to determine if there's an ace or not. So or determine what the face cards and all that stuff. So we go through and we look for what's going on. And really, if you think about it, I don't know why we're doing this for. Because now that I look at it, this is all face card. Okay, no, never mind. This is if it's not a face card. If no face card, no face card, 10 or ace. So at the end here we have the aces. So this is if the card is 2 to 9. Then we just add that value straight to the IC values with card 1. Now, I don't know if this is going to work or not, because this is kind of insane if you think about it. So what's going on here is we have a toy, which wrapped inside of it has call to a vector of a vector, and then the vector inside of the first vector, we're taking the value of the current element and substringing it, and then CSTRing it. So it's like this crazy mess, function calling fest, and I'm not sure if that's going to work or not. But if it does, that'd be awesome, because then I can take what would normally probably be a 2 or 3 extra line thing to go through all this. We can just do it in one line. And then toys it turns the string to an int. Then the card 1 sets it into card 1. The card 1 gets added to the IC values. If the card is a face card or a 10, then we just add 10 to the thing. Now, then we go through and check for the aces. Once all that's done, we'll have all the values for the cards we have. And so we just go through and say, okay, iterate through, add all the values up. So if the number of cards that you have, or number of values, which is essentially the number of cards, is less than 5, we check to see if the total card value is over 21. If it is, then you get busted out. If not, then it just skips through that and nothing else happens. Now, if you have a total of 5 cards and the value is over 21, busted. But if it's less than or equal to 21, then you stand. Because after you have 5 cards, there's no reason to continue, because you've essentially won that hand. And so we just have the player stand automatically. And then we just wait for everyone else's turn to finish. Now, what I have to figure out is how to get how to determine when every player is done with their turn. In other words, if they've surrendered, if they've stood, busted out, or whatever, or gotten to 5 cards. We need to figure out a way to determine that. And I think what we'll do is we'll create a function, not a function, but a variable that'll hold an int. And what we'll say is that at the beginning, well, we'll do 2 of them. One will be the one that we set that'll say, okay, once you reach this value, then the turn, the current game is over, and everyone has either won or lost, and so dole out the chips. And then the other one's going to be, what'll be tracking who has finished. In other words, once somebody has decided to stand, or if they busted out, it'll add 1 to that variable, and then once that variable equals the one that determines if everyone's done, then the game ends, and then it starts again if the player chooses to go for another round. So first I want to get through here and actually finish off the AI for the AI's stuff here. So we have this this message here. This is just kind of determining, mentioning kind of what's going to happen. So up here it has a listing of what's going to happen essentially for dealers and non-dealers. So essentially we're saying dealer always stands greater value than 16, so 17 and higher. AI, non-dealer, will always stand at 19 or higher, but will have decreasing chances to stand for 18 and 17, and never will stand on 16 or lower. Now, that is and is not, well, typically what happens is that unless you're sure that the dealer is going to bust, you will almost never stand on 16, because by standing on 16, you're going to say, okay, so if the dealer gets 17, they win, essentially, or higher. If the dealer gets 17 and you get 17, or if you match the dealer's what the dealer gets, then you essentially get the no bets are changing places. Essentially cancels each other out, so you get all your chips back, and the dealer doesn't take anything. Plus, as it mentions here, and as you probably know, the dealer will never stand unless it's 17 or higher. So if they're on 16, they're always going to take a hit because they have to. So, the way I'm gonna program the AI for right now is that the AI will also do that. The AI players are not dealers. Now down here I made a separate mention about how if the card is a 1 or 11, as just kind of mentioning that how it works, because if you have a blackjack, you're not ever going to use with an ace and a face card or a 10. You're never going to say, okay, ace is 1. You're going to say 11 because that's a win. And I mentioned this here. That's unrealistic because if you have blackjack with an 11 and a face card, then you would just leave it as an 11 and not choose 1. But we're going to leave it as it is now, and I'll just fix it in 0.6. So that's going to open up a whole other can of worms trying to figure out how to deal with that. So essentially what happens here is we're checking for blackjack with an ace, A2, or an A2 and a face card, or a 10. Now we can get rid of this because we don't need it. Let's see, we don't need that, don't need this. We do need a double. It still needs to be doubled up though. The reason we don't need that is because we do it down here, and the reason for that is because we have to do these 2 different ways. We have to do the card 1 and then the card 2. Because of the way that we have to go through now to find the what the ace value is, since we're using a A1, A2 for that. We have to have we have to use card 1 and 2 and 3 and 4 because you can't switch between an if and an else if you can't have anything. Otherwise it breaks the congruency, I guess. So what we do is we just say, okay, we check the first card by using card 1, card 2, and then we check the second card with card 3 and 4. So essentially it's really 1 and 2 and then 2 and 1. But we do it with these because if we do it with those, then we override it and this is no longer correct, because then we're checking card 2 instead of card 1. So a little complicated there, but it has to be done. And then we have to also go through and check any winning combination, or rather any combination under over 16 has to be checked for. Again, because the AI is not going to stand on 16, even if the player does. Sometimes do so. So we have to go and consider A2 for all of that, because 11 plus 8 is going to be 19, 11 plus 7 is going to be 6 and 18, 11 plus 5 is going to be 11 plus 6 is 16. So we have to consider all of that, as well as the 10 and face cards plus whatever value gets it to there. So T through K 7, T through K 8, T through K 9, and also then T through K and T through K for 20. But the non-ace stuff happens in this else down here, because what we're going to do is we're going to have those within this, so that we can use this normal way of using it to check it, because we don't have to do the 1, 2 on the substring, we can go 1, 1, and then use it. You just use those for everything, and do the normal thing like this here. The reason we couldn't do that up here is because we have to have 1, 2, because we have the 2 characters we need to check to essentially pull out of the string. A1, A2. If it was just an A, then we could do that, but at the same time, how would you then choose between 11 and 1? Or would you have to have the player decide what they wanted to do every time you had a situation where that happened? Which is why I decided on this, because this way we only have to ask the player or AI to, to indicate what they want once. Per ace that they have in their hand. So, 20 with ace, we can't actually not, we can't, well, no, we can't have a 20 with an ace. But here's the thing though, we can have more than 2 cards. But we have to check, yeah, this is, so we're checking for only, if there's only 2 cards. In other words, if it's the first hand, or first turn. And then we have to go through and check for all these things. We should probably do something closer to what we did with the player, which is just to go through and say, okay, check the values and whatever it equals, do that. I think that's, maybe we should just do that instead of doing all this crazy crap. This is a lot simpler. But at the same time, we also need to be able to determine how the AI is going to react as far as the actions. Which I guess is what this is really tracking. So this is the first turn actions. We already did the betting, but we haven't done the actions. So this is what that's doing. So everything after the first the first turn, or whenever you have 2 cards, then you go through and determine what's going on. And this is going to run every time you have 2 cards, so, or the AI has 2 cards. So if the AI splits a hand, the dealer will give them another card each, and then they'll be able to go through this whole process again on those hands as well. So that's another thing to consider, though, is also having to do the splits and whatnot. Maybe we should do that first. So all this stuff is about standing, but at the same time, we want to be able to check for splits. Well, if you think about it, though, if any of these is true, except for maybe the 20s, then, well, with 20 that does indicate a split, so that's true. They could split if they wanted to. But yeah, any of these is indicative that there is not a double card, if you will. There's not going to be a card that equals another one, because it's all kind of mutually excluding, that kind of situation, except for the 20s. Uh, 19 to 17 with ace, because like I said, you can't get 20 with an ace as 1 card. Actually, no, you can, can't you? That'd be 11 and 9. True. Durr. Okay, so 20 to 17. So, T card 8-2 and T card 1 equals 9. Two rather, that equals 9. And then we'd do it, again, we would need 3. And we can get rid of all this. But we need to take this and then change it to card 3 and card 4. We'll just put 20 there, so that's what we know we're checking for. Let's say 11 plus 9. So, let's see. Alright, so... Okay, both the dealer and the non-dealer will always stand at 19 or higher, but 18 and 17 have a lowering chance of, decreasing chance of stand, and 16 will never stand. Which is essentially the same with dealer. Except that the dealer is always going to stand 100% of the time when it's 17 or higher, whereas the AI may not stand at 18 and 17 but will not stand at 16 or lower. So you're going to be always... The state of the hand is literally tracked by the hand, so each hand has a separate state. And that was something that I had to do because if you can have multiple hands, how do you check if one hand is still being played and one isn't? And that's how I decided to do it that way. I just put it in the actual hand struct, and that way it could just be tracked from there. So now 19. So only, so we're not including the 9 and 10 or face card. I'm gonna go 1 and 2. And change this to 3 and 4. And same thing. So now, see, 18. Now, here's where we need to start differentiating between the dealer and the AI. If players.at_i.getName equals dealer, else so it's still going to be a fairly high chance of so we'll say rint4, just in case we're using the other rnts for something, equals random greater than or equal to 1, and rint4 is than stand if rint4 is greater than or equal to hit. So we're going to grab the hit code player, and we'll just change it to suit the needs. Alright, so to access the hands and whatever other things you need to do. In this case, we're just pushing back a new card. So change it to rnt3. So that's for 18, so now we need to do, and essentially it's the same process, so we're just going to copy this all, 6. So again, the dealer will always stand. For a little bit lower, we're going to have a less chance of standing, so instead of 23, it'll be if R14 is less than 18. And then if it's greater than 18 or equal to 18, greater or equal to 18, then the for the consider now. And the dealer and the AI were always hit. And in this case, it doesn't matter if there's a double or not, because it won't matter, because unless you have double aces, it's not going to be a situation where that's going to be an issue. ace2, ace1. Ace1 or ace2 though, either way, so we have to check for both of them at the same time. First, let's deal with the 17 or 16 and lowers. So, we have this. That's more of a thing you ask when you go back to refactor. Alright, then this is 16. So, you have card 1 and A2, and then you have to go through and say, okay, if card 1 is 6, or 6 to 2 is what we're checking. 2. Then all we have to do is just select all that and go Control KD to realign it. Random. Let's take this one out because 6 plus 11 is going to be 16. So 11 plus 5 to 2. We'll say 2 instead of doing the dash because it makes it look like 11 plus 5 minus 2. So less than or equal to 16. All of these things. Now, we need to check for double aces. Now, I'm not sure if the dealer double down or not double. To do, you're out. Alright, so if one thing we have to T3 or 1, and then if T card 2. And for right now, we're gonna put this in. So if place dot get name is not equal dealer, then continue. So I'm not sure if dealers can or not, and then we'll just get rid of that, and it'll apply to anyone. So, let's get the player's split code up here and just copy it down because it works just as well as, you know, recreating it from nothing. It's actually a really long bit of code here. What we should also do though is say, as the I2 does, we've gotten a new hand that comes up here. So we have to create a new hand for the player, or in this case the AI. So dot at I dot hands dot pushback players dot at I dot cards dot at 1. Now we have to remove that card from the first hand. So replace that with that. Now that might be something I need to fix, actually. Let's see. Okay, now, so actually what I'm doing with this... Huh. Very interesting. This one, so what we'll do is we'll have to go in this case. So I3 is less than size of bets, our bets. essentially just split the bet, which is whatever the current I2 value is, then the hand will be I plus 1. Then, and you get drawn out another similar card, and you can do that and create a third hand, which will be registered as hand equals, dot hand will be equal to 2 in that case, because it'll be 0 indexed. So now we do the same thing here as up there. Get 2 new random cards, and then those. So remove from the deck. Let's go with the normal split string or substring there. And again, this is all for only 2 cards. So we have to read all this again for more than 2. That'll be a little bit easier value of the cards, etc., etc. And we don't have to check for each one like we do up here, because these are special cases. Alright, so I'm going to miss about code blocks is that statistics plugin. I wonder if there's something similar for Visual Studio. I'll have to look if there is. So, else, air responds more than 2 cards. So we're going to check 20 and lower. So this is for 20. In this case, we want to check for a T or a face card. So essentially we'll just do like this. We'll say if card 1 is a T, T through King, T through K, or if card 2 is T through K. And if card 2 is T through K, then continue. So in this case, though, we're going to use this up here. Well, let's go up to actual T through K stuff. Code from up here. Doesn't really matter where. 18. So here we go. So T card 2 equals equal. And over here we do 1 equals equal. They both stand. Now we can just take this, carry it down 20 or 17, 18. These values here. Alright, and both of them are rather for yeah, for both code we used up here for the dealer non-dealer stuff. 18. That is not. And same for 17, because they both, since they use different values, I'm going to copy paste them from each section. Rather than just go what the values are and changing those directly. Much faster. Wait, that was 17, we want 18. Or 19. I didn't change that. And then we'll do the KD thing. And next going to be or no, we said we were going to do it. I said I was going to do it through there at the top. That's right. No, for the non-2 cards. It has to be And we could have used this, the same convert and use the number, the total value only, but we wouldn't have the control to go and look through for like these here. At the same time, we only have to because it, no, we would have to do this because we couldn't, well, it would be, but then there could be there's other combinations that equal 12 as well. So that's why we have to do it that way, I guess. Makes the most sense anyway. One thing that we have to also take into consideration, though, and we're doing the 16 up here, but that's only doing. So we need to do an else, another else. Damn, that really does not work, does it? So we need another else to deal with. That should be an else. If it's any the other cards, that don't have aces. Well, no. Well, no, yes on that. But actually, we could do that down here in the bottom one. Because this is ace plus any other card, but then we need to also consider non-face card number combinations. Like 5, 4, 2, 1, or 2 and 7, or something like that. 9 and 8. Damn, 9 and 8. So it becomes like a situation of how many ways can you reach, 17. So 19 can only be 9, 9, or a face card and a 9. And double cards are not going to be stood on. They're going to be, usually they're split down. So we're not going to check for that there. 18 is a 10 or an 8. And a 9 and oh no wait, 9 and 9 is 18. So you can only get to 19 with a 10 and a 9. And then, so 17 is the first one that you have anything, a 9 with 2 value cards, non-face cards, or 10 that can get to 17. So I believe it's this one, or T card 1, 9 or 7. So really, if you think about it, there's 4 possible combinations. You can go 1 being 9, 7, and 2 being 7 or 9, or 2. No, I guess, yeah. It's whatever. If you do one way, it automatically card 7, card 2, 7, automatically includes card 7, 2, 7, 1, 9. So I don't have to check both. So only 2 combos. Yeah, you gotta sometimes remember that. So my propensity is to just go through and do every combination possible, when in fact you only have to do half the combinations possible, because that half will also apply in reverse, because it'll equal the same thing, T card 1 equals 9, and then T card 2 equals 7 equals the same thing as T card 2 equals 7, and then T card 1 equals 9. So you only have to do that once. And T card 2 equals 7. Alright, so now if T card 1 is 10 to king and 2 is 7, and if excuse me, damn. This is an instance where it's not included though, because this is different. Now if it was just a single face card, king and 7, then it would. No, actually it wouldn't. I was right though. Because in this case, T card 1 is always 9 and 7. We have to check for T card 1 being 7 and T card 2 being 9. So no, we do have to check that, don't we? We don't check the opposites of what's there, but we check the reverse. In other words, T card 1, and we have to check them. course, it also going to have some pretty long. What this is saying is if card 1 is T decay and card 2 is 7, or if card 2 is T decay and card 1 is 7, or card 1 is 9 and card 2 is 7, or card 1 is 7 and card 2 is 9, then continue with, because it equals 17, and that shouldn't be 7, it should be 8. Derp. Derp, 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 derp. That's for 16, not 17. Once again, I've proven I fail at basic math. Alright, so dealer will stand, but if not dealer, then you have a chance not to stand, but to take a hit. Now up here, like I said, you can only get 18 with numbers by 9 and 9, so you don't have to double, and that's going to be split. 17. Now what we do is we just take all we have to do now. Actually, no, because what we can do now is essentially say, no, yeah, we have to check for T everything down from, well, no. What we do with this now is say this 16 and lower. The problem here though is that we have to deal with the fact that T card 2 can be anything from 6 to 6 to 2. And then we have to deal with the fact that up here, any of these numbers can be if added together will still equal over 16 in this case. Like 7 and 9, so, or rather 9 and 8. So we have to consider it being between 9 and 7 and lower. So if T card 1 is 9 and T card 2 is 7, 6, 5, 4, 3, 2, or if T card 1 is 7, 6, 5, 4, 3, 2 and T card 9. Let's see. There's definitely a problem with my thinking here. Okay, so what we'll do is we'll say as if these are for face cards, non-aces. We need to do one that's only for the numbers and not for anything else. So what we need to do now is no, we still need to do 6. Now, in the case of 20 with 2 face cards, or 2 10s, it's always going to be stand no matter what, because not a split. Well, that'd be for the dealer. I think we'll go ahead and what we'll do is we'll say, okay, the dealer will stand, but since it's a double, I'm going to put a 2-do here. We'll have to, so 2-do. What I'll also have to come back there and do is say, okay, let me put another 2-do here. 2-do on values 16 and lower. Add a chance for double down. Now I'll put another 2-do. And are no longer playing. And that's really for everything. I'm gonna put it there though, just because. Alright, so if I look and see that the dealers can split, then what I'll do is we'll have a splitable instance there, and we'll also do it for 19. iCard 2, T card 2. So essentially it's the same as what we had up here. Wherever the hell it's at. For the aces. Except it'll be one extra now. We'll have 6 instead of 5 through 2. 6 through 2. What's going on? Because it must have been up here. Because we got T card 1, 1, 1, 2, but then if we go over here to the okay, where the hell did I add that to? Okay, so here's T card 1 and 2. So I got it from here on the 16, right? Or 17. I must have accidentally not included that, the 7 there. For some reason. Odd. Okay, so T card 2. And same thing here. Except change these all to 1. Alright, so if T card 1 is T to king and T card 2 is 6 to 2, or if T card 2 is T to king and T card 1 is 6 to 2, then continue. And this is going to be an instance of always hitting. But again, like I said, through and add in the code for now we have to deal with to also consider here. Well, that'll be number. And so that'll come down here. Because it'll be an 8 and an 8. And you can't check for 8s here. This is a face card 9. So, first we need to cast to int the cards. So we'll use card 1, 2, 3, 4, and well, yeah, there's only going to be 2 cards, so just card 1 and 2, that's right. So we're still in the 2 card section here. So, card 1 equals toy. Then again, we're doing that huge, 5 function thing again. Substring. One. You can just easily do it this way. If card 1 equals card 2. And we have the chance always do it, and it gives you potentially twice as much return. So where's our splits code here? In this case, I don't know. That's right. We don't know. Alright. Any other combo? So we'll just say else. In this case, it's always going to be a hit. Well, else if T card 1 or card 1 plus card 2 is less than or equal to 16. And else. So well, and 16 first. I said 9 and 8 will still be 17. And although that's accounted for up here, we still want to account for it just in case yeah, something goes wrong up there. In case it gets caught through this somehow. For whatever reason. So essentially how this works now is it's essentially like a filter. If else ifs. And so if we get through the first block, neither the cards are aces. If we get through the second block of if else ifs, then that means there are no face cards. Because that's what's primarily being checked in this second one. And so when we get to the third one, you can be pretty much reasonably assured that it's only going to be numbers. No face cards or 10, and no aces. Just 229 is what the card will be. Either, and it ends 6-3. Lines long so far. Maybe even over 1,100. Well, 5-4-6-3, 6-5-6-3. I think I said 5-4-6-3, didn't I? Yeah, almost. It could be 1,000. 5-4-6-3. Oh wow, cool. It's exactly 1,100 lines long right now, and I have no clue how I just decided to stop there. Check it. But that's gonna be it for now. I may record earlier, so I'm not gonna end this like I normally do. I'm just gonna cut the recording, and then if we do record more, I'll just tack it on. If not, then we'll just have to do it at the normal ending. So until next time, it's GOL, and I will.